All right, here we go with our day 2 notes on 1-5, solving inequalities in one variable. Today we're going to be talking about solving these inequalities as well as graphing them on a number line. But before we do that, I want to talk about how the different operations affect the inequality, particularly when dealing with negatives. Let's take a look at our table here. Here I consider three cases. 1 is less than 3, 4 is greater than 2, and negative 2 is less than 1. Let's go ahead and add negative 1 to both sides of the inequality to see if it's still true. So on the left-hand side, we have 1 plus negative 1. We have less than. On the right-hand side, 3 plus negative 1. Well, let's go ahead and evaluate both sides. 1 plus negative 1 is 0. Bring down our less than. 3 plus negative 1, we have positive 2. Now, is this still true? Is 0 less than 2? That is true. Let's try it with a greater than. 4 is greater than 2. Let's add negative 1 to both sides. So 4 plus negative 1 greater than 2 plus negative 1. Well, 4 plus negative 1 is positive 3 greater than 2 plus negative 1 is positive 1. Is 3 greater than positive 1? That is true. I'll leave the third column for you to do. Let's subtract negative 1 from both sides. So let's return to this first column. 1 is less than 3. Let's subtract negative 1. So we have 1 minus negative 1 less than 3 minus negative 1. And notice I'm using parentheses. So 1 minus negative 1, that's the same as adding positive 1. So we have positive 2 is less than 3 minus negative 1. Again, same as adding a positive 1. We have 4. Is 2 less than 4? That is true, yes. Let's try it with greater than. We have 4 minus negative 1 is greater than 2 minus negative 1. Well, let's see. 4 minus negative 1, that's positive 5, greater than 2 minus negative 1, that's positive 3. Is 5 greater than 3? Yes, it is. So this is true. Again, I'll leave that third column for you to do on your own. Let's try multiplying. So let's multiply both sides by negative 1. So on the left-hand side, we have 1 times negative 1. We have less than 3 times negative 1. Let's see what we get. 1 times negative 1, we get negative 1. Bring down our less than. 3 times negative 1, that's negative 3. Well, let's see. Is negative 1 less than negative 3? No. Negative 3 is less than negative 1. So this is false. Let's try another one. We have 4 and 2. So 4 times negative 1 greater than 2 times negative 1. Let's see. 4 times negative 1 is negative 4. Greater than 2 times negative 1 is negative 2. Is negative 4 greater than negative 2? No, that is false. Negative 2 is greater than negative 4. So this is false. And last but not least, let's divide both sides by negative 1. So we have 1 over negative 1. I'm going to use fractions to show division. We have less than 3 over negative 1. Well, 1 divided by negative 1, that's just negative 1. Bring down our less than. We have 3 divided by negative 1. Again, that's negative 3. Is negative 1 less than negative 3? No, that's false. So we can write that. Let's try one more. 4 divided by negative 1 greater than 2 divided by negative 1. We have negative 4 greater than negative 2. Is that true or false? Negative 4 is not greater than negative 2. That is false. So notice that we have true for these 4 boxes up here, but false for these 4 boxes down here. So for the ones that are not true, or the ones that are false, how can we make them true? So how can we make these true? In order to make these true, we have to flip the inequality. Flip the inequality. If we were to flip this inequality, we'd have 1 is greater than negative 3. That's true. Negative 4 is less than negative 2. That would be true. 1 is greater than negative 3. Again, true. And negative 4 is less than negative 2. That would also be true. So if we flip the inequality for all of these, we would get that they are true. So notice that occurs anytime we multiply or divide by negative 1. But we can generalize and say this is true for all negative numbers. So let's go ahead and write that. Put a star next to it, big exclamation marks. If you multiply or divide by a negative, flip the inequality. And I'm putting that in all caps. So put a big star next to this, put exclamation marks. If you multiply or divide by a negative, flip the inequality. Okay? So make sure that is big and bold in your notes. All right, we're going to move on to page 6. Go ahead and flip the page. Now we're going to talk about solving these inequalities. Now before we solve, I just want to go over the steps to solve. We're going to solve these just like equations. So you can write at the top, solve as usual. We're going to solve them just like equations, so reverse PEMDAS. Whatever you do to the left, you got to do the right. I'm also going to rewrite that note. If you multiply or divide by a negative, you have to flip the inequality. If you multiply or divide by a negative, flip the inequality. All right, let's try a few examples. Let's try number 11. So number 11, we have 5b minus 1 is greater than or equal to negative 11. We're going to solve as usual. Let's deal with that addition and subtraction first. See, we have minus 1, so we add 1 to both sides, and we get 5b is greater than or equal to negative 11 plus 1, that's negative 10. One more step, we divide both sides by 5, and we get b is greater than or equal to negative 2. Now notice that I didn't flip the inequality here. The reason why is we're dividing by positive. Dividing by 5 is positive, so we don't have to flip the inequality, even though our solution is negative. So in order to graph this on a number line, we first have to label our number line. I like to start with 0 and then just count out a few units in each direction. So 0, 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. Our solution is always going to be whatever b is related to. So in this case, negative 2. Now, whenever it's greater than or equal to, or less than or equal to, if we got that or equal to, we're going to have a filled in circle. So I'm going to do a filled in circle on negative 2. Now we have b is greater than or equal to negative 2. So I'm going to shade in all of the numbers that are greater than negative 2, or all the numbers to the right. So I'm going to shade in my number line. And I'm going to put arrowheads at the end of that shading because this continues on infinitely in the positive direction. So make sure you have that arrowhead as well. Let's try another. Let's do number 12. So we have 37 is less than 7 minus 10w. So the first step here, deal with that addition and subtraction. I'm going to subtract 7 from both sides. And we get positive 30 is less than negative 10w. Again, notice I did not flip the inequality. We're only subtracting 7. We're not multiplying or dividing by a negative. Our next step, we divide by negative 10. So I'm dividing both sides by negative 10. We get negative 3. And we have w. But what's our sign? Well, right now it's less than, but we're dividing by a negative. So what do we got to do with that inequality? We got to flip it. So instead of less than, we have greater than. So our solution, w, or negative 3 is greater than w. So let's go ahead and plot that on the number line. Again, 0, 1, 2, 3, 4. Negative 1, negative 2, negative 3, negative 4. You can go ahead as far as you want. Just make sure that you have your solution in there. Sometimes it's helpful for me to visualize what the graph is going to look like when I flip this inequality. So I have 3 is greater than w. You can also flip the entire thing and say that your solution, w, is less than negative 3. So notice everything on the left moved to the right, everything on the right moved to the left, and we flip the inequality. You can write your solution either way. I prefer to have my variable on the left-hand side because that helps me visualize what the graph might look like. I have w is less than negative 3. These are the same solution. So we're going to find our solution, negative 3. And because we have just less than or just greater than, it's not equal to, we're going to have an open circle at negative 3. So let's draw in an open circle on negative 3. And now we want to shade in everything less than negative 3. Okay, so we're going to shade in the left-hand side of the number line. And don't forget those arrowheads. That extends infinitely in the negative direction. If you're fine with this solution, negative 3 is greater than w. That's saying that all solutions of w, negative 3 is greater than that. So you're going to shade in the left-hand side. Again, either way is fine. You can choose which way you prefer. Let's try one more. Let's try number 14. So here I have variables on both sides of the inequality. So step 1 is to choose a side for the variables and choose a side for the numbers. I'm going to choose the left-hand side for the variables, the right-hand side for the numbers. So we have to move all the numbers to the right-hand side. I'm going to move this minus 6 to the right-hand side. So the left-hand side cancels. We're just left with 3h is greater than or equal to 15 plus 6, that's 21, plus 24h. So we moved all the numbers to the right. We got to move all the variables to the left. I'm going to subtract 24 from both sides, 24h from both sides. So we have 3 minus 24, that's negative 21h, is greater than or equal to positive 21. We got one more step. We're going to divide both sides by negative 21. And we have h is less than or equal to. Don't forget to flip that inequality. We're dividing by a negative, and we get the solution. 21 divided by negative 21, negative 1. So that's our solution. H is less than or equal to negative 1. Let's go ahead and graph this on the number line. 0, 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. And our solution is at negative 1. Now, as an open circle or a closed circle, we have less than or equal to, so this is going to be a closed circle. H is less than or equal to negative 1, so we're going to shade in everything on the left-hand side. So shade in that left-hand side, draw those arrowheads, and it extends infinitely. The other 3 practice problems on this page are for you to practice. Go ahead and pause the video, complete those, and then unpause when you want to check your work. All right, go ahead and check your work. A couple things to note on this one. Notice for number 15, we got that the variables canceled. We had 6 is less than 28. Now we have to determine whether or not this is true or false. Well, 6 is less than 28. That's true. So our solution is all real numbers. What that means is we can plug in any number for C, and we're going to get that inequality always is true. I also want to note on 16, notice that my increments, I've spaced them out a bit. So you don't have to have every increment is 1 unit. You can have every 4 units is 1 unit, or every 4 increments is 1 unit, meaning every increment is a quarter unit. So however you want to do that, whatever makes the most sense to you, you can certainly do that. All right, so this is 1-5 solving inequalities. We're going to get a whole lot of practice on this. We'll see you tomorrow in class. Have a great day, everyone.